Hey guys, distance formula today. Talking about trying to find the distance between 2 points on the coordinate plane. And so I'm going to give you a couple different ways to do that. One is the Pythagorean theorem, which may sound familiar to you. You learned that in Algebra 1. And the other way to find the distance between 2 points is what's called the distance formula. And I will show that to you later on down the road. So the main goal today is to actually find the distance between 2 points. So that's what we're going to focus on. This should be a quick one. So let's get started. The first part of your notes here is review. I'm just kind of asking you to reacclimate yourself with the coordinate plane, which is obviously this structure right here. So the first thing, there's a list here right down the line, and we're just going to go down the line and talk about each one and mark it. Okay, so the first one is the origin, and the origin is always right smack dab in the middle, and that's always the point of 0, 0. Okay, quadrant 1, 2, 3, and 4, those are the next ones on the list, and we'll kind of just go right in order. This is quadrant 1. Okay, quadrant 1 is this area right in here. Quadrant 2 is over here. Quadrant 3 and quadrant 4. Now I know I'm labeling outside of the coordinate plane, but again, this is 1. Everything in this space here is 2. Everything down in here is 3. And everything over in this section or quadrant is 4. The x-axis is clearly labeled here. The x-axis always runs from the left all the way across the right. You can see the x there. And the y-axis runs vertical, so up and down, that is the y-axis. The next 3 or 4 things is asking you to do is just to graph points so that you get used to graphing those again. So the first one is 4, 5. Just a reminder, when you graph a point is always x, comma, y. Okay, so when you graph a point, you always graph the x-coordinate first. So for point A, where it says 4, 5, we're going to go on the x-axis, since it's the first one listed, 4 units, and then 5 units up. So 1, 2, 3, 4, 1, 2, 3, 4, and 5. That should be up here. That's point A. Point B is negative 2, comma 0. So since it's negative and it's the x-coordinate, we're going to go to the left, 1, 2, and since it's 0, we would mark it right there. So that's a good indication when it's negative that you're going to be going to the left, and this is right. Because remember, this is just a number line. This is the origin is 0, comma 0. This is 1, 2, 3, 4, 5 to the right, and then negative 1, negative 2, negative 3, negative 4, negative 5, and so on to the left. Let's go to the next point, 0, 3. So 0 is our x-coordinate, which means you're going to move 0 units on the x-axis. So you're basically starting at the origin and you're stationary. Then you're going to go 3 units up, 1, 2, 3. So we're going to call that point C. Again, this was point B down here. Point D is 4, 0, so you're going to move 4 units on the x-axis, 1, 2, 3, 4, and it's a 0 for the y, so it stays right there. The next one says to count the length of segment BD. Okay, so here's B, and here's D. This is kind of review. We just start at B, so 1, 2, 3, 4, 5, 6. So that would be 6 units. The length of AD is just 1, 2, 3, 4, 5. Now, to find the distance between 2 points of any horizontal or vertical line, you can just do what we just did for these 2 examples here for BD and AD. You can literally just take your pen or your finger and count. So you may be asking, okay, then why do we need the distance formula? Or what is the distance formula for? The distance formula is used if you need to define, for example, the distance between point C and point A. Those are not on a vertical line or a horizontal line. They're on a diagonal line, and we can't count here. All right, we have to find the actual distance. But again, any vertical line from A to D, you can just count. All right. So let's jump down and actually get into the distance formula. And I'm going to teach you 2 ways. The first way is going to be using the Pythagorean theorem. And I'm going to write the Pythagorean theorem down for you so that you can remember it. But remember, the Pythagorean theorem is a squared plus b squared equaling c squared. All right? Pythagorean theorem. Good to know. So I'm going to show you how to use the Pythagorean theorem here. First thing you want to do is you want to plot the points. So the first point here is 1, 5. So 1 and then 1, 2, 3, 4, 5. Put that there. That's point A. And then I have 4, negative 1. So I'm going to go to the right 4. 1, 2, 3, 4, and down 1. Alright, so we need to find the actual distance between those points. If you're using the Pythagorean theorem method, what you need to do first is you need to draw a right triangle. Or you want to create a right triangle from those 2 points. And you can do this a couple different ways. Some students may draw down, and in fact that's what I'm going to do. I'm going to draw down, draw over, and then I'm going to connect the lines there. So essentially you want to make a right triangle, which includes then a vertical and a horizontal line. Now, we just talked about how to find the distance between 2 points if it's a vertical line or a horizontal line, and we can do that. So watch how this works. 1, 2, 3. So this bottom part is 3 units. This vertical distance would be 1, 2, 3, 4, 5, 6. So we'd put a 6 there. And I know it may be kind of hard to see that 6 there, but it is. And now we can use Pythagorean theorem. We want to find the distance between these 2 points on the diagonal. I'll call it x. So we set up using Pythagorean theorem. So we're going to go 6 squared plus 3 squared equals x squared. 6 squared is 36. 3 squared is 9. 36 and 9 make 45, equaling x squared. Now you may remember from your Algebra 1 days, how do you solve for x squared? What's the opposite operation of something squared? You square root both sides. Okay. Now if you look at the directions say right here, leave your answer in simplest radical form. This is difficult for a lot of geometry students because they forget how to break down this 45. Some of you may have learned making factor trees, and some of you may have been taught to find the greatest common, or the largest perfect square, the largest perfect square that can go into 45. Now this may be something I'll show to you tomorrow, but I'm going to go through this one fairly quickly. I know that the largest perfect square that goes into 45 is 9, and what's left over, what times 9 gives you 45 but a 5? The square root of 9 is 3. Kind of running out of space here. And the square root of 5 you can't take any further. The square root of x squared is just x, so our answer is 3 radical 5. Okay, so that's the distance between those 2 points. The one right to the right of it you can still see in your screen. If you want to hit pause and try it, do it. I'll check back with you in a minute. Alright, we're back. So the first thing we want to do is plot these points. So negative 1, 3. 1, 2, 3. And 3, 6. Start at 0, 0. 1, 2, 3. 1, 2, 3, 4, 5, 6. And we have to find the distance between those 2 points there. Even if you draw in that diagonal, that's what you have to find. Now you want to create a right triangle. You can do this in a couple different ways. Most students are usually going to go down either right or to the left to create that horizontal and vertical line to make that right triangle. And then you just count with your finger 1, 2, 3, 4. So that bottom part is just 4 units. The top part 1, 2, 3, 3 units. Okay? Pythagorean theorem. You want to find x. So we're going to have 4 squared plus 3 squared equals x squared. That's 16 and 9. 16 and 9 make 25. Square root. This one works out really nice, and we just get plain old 5. So the distance between those 2 points there is 5. All right? Let's flip it back over. Flip your notes over to the other side here, and we'll talk about a situation where you'll see in your notes here, if I can get it on the screen. Look at your 2 points. 56, 1, and 53, 0. All right? Now you don't have enough space on your coordinate plane to do this. So when you don't have points that fit on your coordinate plane, this is when it's a good idea to use the distance formula. So right underneath this coordinate plane, it says the formula for finding the distance between 2 points. So this is the second way to find the distance besides using the Pythagorean theorem. So here's the distance formula. D equals the square root of, notice it's a big square root, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay? You don't have to memorize this. This will be given to you on any quiz or test that we take on a formula sheet, but it's not a bad idea to put it to memory. Now you may be wondering what x2 and x1 and y2 and y1 are. I'll show you in this problem right above it. Okay? So anytime you have points and you're going to use the distance formula, you want to label your points x and y. Now the only reason I put the ones here is because it's the first point listed. Over here I'm going to put x2 and y2 because those are the second points listed. Okay, so that's where those numbers come into play. Now all you're going to do is, and I'm going to kind of give you a little bit of a visual here. So my x1 value is 56, my y1 value is 1, my x2 value 53, my y2 value is 0. Okay? And all you're going to do is you're going to plug those into the formula. So let's do that. My x2 is 53, subtract my x1 is 56, my y2 is a 0, and my y1 is a 1. And then you're going to simplify what's inside the parentheses because order of operations tells us to do that. Okay? So I'm going to have 53 minus 56 is a negative 3 squared plus negative 1 squared. Negative 3 squared is 9 and negative 1 squared is 1. So I end up getting the square root of 10. So the distance between those 2 points, E and F, is the square root of 10. Now, you look to see to simplify this, but you can't. You can't simplify the square root of 10 any further. That's what we call simplest radical form, and that would be our distance. Okay? Little real-world application problem at the bottom of your notes. Again, it's pretty basic. If you read the question, it says each morning Juanita takes the blue line, all right, which is a name for a subway, from Oak Station to Jackson Station. And you can keep reading through down the line. At the bottom it says find the distance Juanita travels between Oak Station and Jackson Station. Well, here's Oak right here. And here's Jackson right here. And you have to find the distance between those two. I'm actually going to use the distance formula. I know there's going to be students who go ahead and draw in and make a right triangle. 1, 2, 3, that's 3 units. 1, 2, 3, 4, 5, 6, that's 6 units, and do Pythagorean theorem, right? Call that x, or the distance, so that would be 3 squared plus 6 squared equals x squared, and you can do it that way. Now, what I'd like you to do real quick is hit pause and use the distance formula to find the distance between these 2 points. I'll check back with you here in a second. Alright, we're back. So, Oak is negative 1, negative 2. That's Oak Station's point. Jackson is 2, 4. Now I'm a labeler, so I'm going to label my points. This is my x1, this is my y1, this is my x2, this is my y2. And I'm going to use the distance formula. x2 minus x1 squared plus y2 minus y1 quantity squared. And you're going to plug in these values for your x1, x2, etc. Okay, let's do it. x2 is 2 minus your x1, which is a negative 1. Now notice what I did. It's 2 subtract a negative 1. You know what's going to happen there. Well, let's just wait for a second and write everything else in. My y2 is 4. Subtract. My y1 is also a negative number. It's a negative 2. Now I like to show this. Some of you may just do it in your head. In the distance formula, remember, these are always negative signs. The only time those are going to change to plus signs is if your x1 or y1 are also negative. You can see it right here. Double negatives become a positive. So that becomes 2 plus 1, which is 3 squared. 3 squared is 9. 4 minus a minus 2 becomes 6. 6 squared is 36, and you get 9 and 36, which is 45. We kind of had one like this on the front, if I'm not mistaken, the square root of 45. Okay, so I'm actually going to do the factor tree. I'm just going to pick two numbers that make 45. Actually, you know what? Because it's 45, I know that 9 is going to work. I want to show you the factor tree just in case here. So 9 and 5, I know 9 can break down into 3 and 3. If you remember when you did a factor tree, you would always circle your prime numbers, and then you would always look for pairs. So you may remember this in algebra, but I have a pair of 3s. When you have a pair of 3s, they just come out as a 3. And anytime you just have a single number like 5, that just stays as a leftover. Okay, so your answer would be 3 radical 5. All right? So that's the distance formula. Remember our learning targets were to find the distance between 2 points. We did 2 methods today. I showed you the way where you just use Pythagorean theorem, where you're drawing in your vertical line and horizontal line to connect that diagonal, and then also the distance formula, which you don't have to memorize, but it'd be a good idea to know. All right? Hope this goes okay for you, and again, I'll answer any questions you have in class tomorrow. All right, take care. We'll see you.